What is up, AP Stats? It's Coach Jay here. Hope you're having a phenomenal day, winter break day today. Got a lot of stuff going on over winter break, a lot of mission trips, a lot of traveling, and then also a lot of sporting events at GAC. So just hope whatever you're doing well with that and having a good one. I hope this podcast is both helpful and quick. You're going to notice that a lot of this stuff that we're going to talk about, stuff we've kind of already addressed, just one little new concept with this 9.3 day 2 that I really wanted to hit on. And so buckle up and get your phone out. Go ahead and scan this right here. It should pull up a test here. And if it doesn't pull that up, let's say it looks like this, you could actually go to, you could Google this. Like it's the stats Statlet, I believe is what it's called. But if you go statistical applet, statistical power, it should look like this. You could follow me, and that's fine. But for those of you who really like to do it, that might be helpful for you here. All right, so as we get started, some of this stuff we've already done probably in class. So just go ahead and pick up wherever we left off in class, and then we'll go from there. So the national mean score on the math portion of the SAT is 511, and it gives the standard deviation. We believe the students at GAC have a higher mean than the national average. So we take a random sample of 8 students, that being our little n sample size, and find their average. We'll then use the data to conduct a significance test with that at a 0.05 level. All right, so let's write the hypothesis. And maybe you want to pause this and try it out yourself before checking with me. We're in mean world, so we know that's true. The null is kind of what the standard is, and we're trying to compare it to the 511. And what we're saying is that it's higher than that 511. And obviously the mu would be the true mean score on SAT for GAC students. Okay, that's pretty simple. Now what you're going to do is you're going to go to the Statlet here once you've done this, and you're going to go on number 2, which just basically means we're going to plug in all the different parts right here that you see. Today we're going to look at this, and that's really what goes here. We have this value that we have called power, which basically is the probability that we'll find convincing evidence against the null hypothesis. The higher the power, the more obviously probability we have of getting convincing evidence against that null hypothesis. Now here's what's cool. You do not have to solve for power. So all we need to do is interpret and then also know what affects it, meaning what increases or decreases it. So let's look at this. As we look at this specific example, you'll see this thing called power here, and that's the probability. By the way, power is not p-value, so make sure of that. This is different. Power is the probability that we'll find convincing evidence against the null hypothesis. Again, I don't have to solve for it. You will get this number. So what is the probability that the test will find convincing evidence against the null hypothesis? Well, that is the definition of power, which in this case is 0.14. Now, interpreting this value is important. So if I gave you, hey, this is the power, how do you interpret it? First of all, you could sing the song, I got the power, if you want to, but you don't have to. You can just simply write this down, interpreting value, and it would be this. This would be the interpretation. If the mean SAT score at GAC is 535, basically what that was, it's the alternate mu, meaning it's from my population that I'm looking at from the mu that we interpreted. Okay. Yeah, normally we wouldn't know that, but this is something that again just helps us with our interpretation and in finding what it would be in context. If the mean SAT score at GAC is 535, there is a 14% probability of finding of the test giving, or finding, we'll say of the test, giving convincing evidence for the alternative, which is that our true mu is greater than our 511 mark. You could also, right here, just a heads up, probability of a test giving convincing evidence. And this, you know this based off of what we said. For the alternative, we could also say convincing evidence to reject the null, which is that our true mu is equal to 511, which means if we reject the null, then we accept the alternative and because we have convincing evidence. So let's say that again. If the mean SAT score at GAC is 535, this is the big part. There is a blank percent. This would be called our power, right? So there is a 14% because it pulls back from here. Probability of the test giving convincing evidence for the alternative. That's really the definition of power. And that's what we're looking at when we go into power. So really we got three interpretations that are big now. We've got power, we've got p-value, and we've got our regular conclusion. So that's something just to kind of hold back to just in your back pocket as we're going through this, okay? So then we're going to look at what increases the power, what affects the power. We'll just look at our example. We really are looking at three things, just A, B, and C. And we'll wrap it up from there. That's really all we need to know there. So let's go, and then we'll go to the golden nugget. So let's go here. Let's affect the sample size. As we increase the sample size, look what happens to the power. So we go from 8, let's just make it to 100. You'll notice that the power increases, right? So as the sample size increases, so as sample size increases, power also increases as well, okay? All right, let's look at our alpha level. So we'll put this back to 8 just so we can update that. So if our alpha level increases, look what happens to the power. The power decreases. So as alpha, oh, I'm sorry, hold up. That's increasing, my fault. I don't know why they have it backwards like that. As we increase the alpha level, that's strange. As we increase the alpha level, so does the power. So same thing. So as our alpha level increases, meaning gets larger from 0.05 to 0.1, our power will also increase. These are really good multiple choice. There's at least one of these on the AP exam usually when we go back through and look at it. And then our last one is our alternative mu. So if you look at our alternative mu, this depends. Let's say we have a good year this year because our seniors are so smart. We'll go right here, 555. And when I update this, if it increases, then notice also that the power increases as well. I'm just making sure. Perfect. And so really what it is, and I wanted to just look at my notes here. So I would say as the distance between the null and the alternative increases, our power, I'll say power increases as well. So if you remember, I changed this to 555, and remember our null was 511. This was greater than what was it, 535 that I put. So the greater the distance, the power also increases. The fact that we have a higher probability of the test giving convincing evidence. So just be careful, make sure that you know that. You don't have to, again, solve for power. It's more interpreting and knowing number 3. So let's just go over a quick golden nugget. We'll put this down and then we'll be done. Pretty simple here. Power interpretation. So this is just how we interpret this. All right, let's just put this up here. Assuming the true mean is whatever it is, and this in our example is 535. And then this is where we put there is a blank probability, and that's where you put the power, by the way. Blank probability of finding convincing evidence against the null. Against the null, and this is where we could say finding evidence for the alternative. You could say that as well. In fact, that's what they probably prefer. Whatever our alternative would be, that's what we put in here. We put in mu as greater than 511. That was kind of what we put in. But you would put this bottom part in for that right there. Kind of it's saying the same thing. I probably would use the bottom one. I see that more or less within a lot of the things that they're requiring us to do. All right, last thing, here we go. This is our decision. And then this is the truth, okay? So as we look at our decision and truth, we know that we could do a couple things, right? We could reject the null, or we could fail to reject, right? I'll just say fail, okay? Over on the top, we would say the null is true. We've seen this before, right? And then over here, this is the alternative is true. Okay. If we reject the null, but the null is true, that's type 1, right? We've seen this. If we reject the null and the alternative is true, that is that's good. That's just a check mark. If we fail to reject, but the null is true, that's okay. But if we say we fail to reject and the alternative is true, this is type 2, right? We've already seen this. Now, how does power relate with this? Well, we actually have this one little thing that we say, the probability of giving a type 1 error, we've already done it, is equal to my alpha level, right? In the previous example, it was 0.05. So the probability of getting a type 1 error all stems from whatever the alpha level is there. This next part is our last thing here, and it's probability of type 2. That is equal to 1 minus my power. So you look at the original example is 14%. So the probability of a type 2 error occurring, meaning that we fail to reject the null but the alternative is true, that would stem from my power. Again, I don't ever have to solve for power, but if I get the power, then I know that I can solve for that type 2 error. So that would be 1 minus 0.14, which equals 0.86. So 0.86 or 86% is the probability of a type 2 error occurring, meaning that I fail to reject the null, but the alternative would be true. So these two right here, just making sure you know the formulas for that. 1 minus power, and then the alpha level, knowing how to find the probabilities of those errors. That's there, okay? Here's the check your understanding, just kind of the last problem that if you want to check out, and then you could pause this here because I'm going to give you the answers, which is here. So you could go ahead and check that out. Goes through these two we just did, the probability of type 1 and type 2 error. That may help you just getting that extra rep in. All right, y'all have a great winter break, and if y'all have any questions, shoot them my way. We'll see y'all.